Hi guys, how are you doing? Hope you're doing great. So this is Dr. Sara, your physics teacher, and I'm happy to be recording these sessions for you to get back to these sessions each and every time for revision. And this week we started by a comparison between mass and volume. As far as I remember, we started by telling you the story about the process you do whenever you're visiting an ice cream store. So there's a very big difference between visiting one of the shops like Baskin-Robbins or Cold Stone, right? And visiting a frozen yogurt ice cream. And I have already discussed with you that whenever you are in a frozen yogurt ice cream, you make a different process, right? Which is first you select or you choose the size of the cup, then you are filling the cup with the ice cream and then the flavors and nuts and M&Ms. Then you go to the cashier and you have their weight. Now you can pay for it. While in the other ice cream shops, you are paying for the scoop, right? So it's a different process. And why did I tell you this story? Because I need you to figure out the difference between mass and volume, right? So we agreed that the size of the cup is the volume, while what you have filled inside the cup with ice cream or whatsoever is the mass. So there is a very big difference between the mass and the volume, right? And we have to measure them correctly. So let's start by the mass. By definition, the mass is the amount of matter in an object, right? And this is the ice cream that you have filled. Okay, and we have some masses that are big, others are small, and others are very small. So here on the screen, we just need to figure out the tool or the device we use to measure the big and the small and minute masses, the very small masses, and to figure out what is the unit. After you calculate everything, you need to write the unit correctly because you're going to be graded for at least 1 mark for the unit. Okay, so big masses are usually measured in kilograms, right, or tons. Okay, and we usually measure them by using the balance. Yes, that's correct. Now the small masses, the unit is the gram, while we use the digital balance or even the normal balance. Digital balance is just giving you some more accurate results. Now, when it comes to the minute masses or the very small masses, like a golden ring, or if you are doing a chemical reactions in the lab, so you just need the milligrams as the unit, okay? And you use the digital balance as well because it's very sensitive. You can also call it a sensitive balance. Right now, when it comes to the volume is the space occupied by an object. Okay, and now we either measure the liquid's volume or the solids. For the liquids, we usually use the graduated cylinder, and you know this. Now the unit is the centimeter cube or the milliliters, while the liter is for the volumes that are really big. Okay, but for the measuring cylinder, it's only milliliters, or you can call it centimeter cube. Now, when it comes for the solids, we have two scenarios. Either the solid is regular shape, so this means that it has a regular or definite dimensions. You can easily measure it by using a ruler, right? Or it could be an irregular solid. Okay, so if it's irregular, you just need a ruler. While if the shape is irregular, like a piece of rock or a ring, for example, you just need a certain procedure to follow, which is using a graduated cylinder, and we are going to explain this in detail in a while. Okay, in both scenarios, we are going to use the centimeter cube as the unit for measuring any small volume. If it's a big volume, it's meter cube. Okay, and I have already explained why do we mention the 3 or the cube, because it's 3 dimensions. The volume is a 3-dimensional property. For example, for the book, volume is length by width by height. So we multiply 3 dimensions. That's why we use the centimeter cube, right? Now, regarding measuring the volume of the liquid, I have demonstrated for you that normally the surface of the liquid is not straight, and it's forming a curved surface. This surface we called a meniscus. So by definition, the meniscus is the U-shape or the curved surface of the liquid, right? And in this time, in order to have the measurement correctly, you just need to look at the bottom of the meniscus and not at the top to get the measurement correctly. Okay? And this always happens in water. Okay, while mercury, as I have already explained, is forming another meniscus, and this time you look at the top of the meniscus, but this information you don't have to study. Okay, now the second rule, after you measure, whenever you are going to measure the volume of a liquid, first thing you need to look at the bottom of the meniscus. The second thing you need to take care about is to keep the tube or the beaker or the measuring cylinder at the same level, to take the reading at the same level of your eyes. Never look from the bottom or from the top. Okay, so this is the correct procedure. You look at the same level and you put the beaker or the cylinder on a flat surface, right? Because on a curved surface or an inclined surface, the reading is not going to be correct. Now, we have already measured this and done this activity in the classroom. Here, you look at the bottom of the meniscus and then you take the reading correctly. Watch out that between the bottom of the meniscus and the top of the meniscus, there is approximately like 1 milliliter difference, right? Okay, now when it comes to measuring the volume of a regular solid object like a piece of rock, for example, now we put a certain or a suitable amount of water in the measuring cylinder, for example 50 milliliters as shown. Then we put the rock. Okay, so now the rock is going to displace or take the place of some water. So the water level now is going to rise up to 75 milliliters. So by logic, now if you're going to find only the volume of the rock, simply you subtract the second volume from, or the second reading from the first reading. The second volume from, the first volume minus the second volume, or subtract them from each other. Okay, so the bigger one minus the smaller one, 75 minus 50, so we get 25 milliliters. This is actually the volume of the rock. Here we go. Now, simply by applying the same formula, you get that the volume of the stone is 90 centimeter cube by subtracting 180 centimeter cube minus from 270 centimeter cube. Okay, now for measuring the volume of a regular solid, you just simply need to multiply the dimensions. The dimensions that you have for a cube are length and width and height. Here 10 multiply 8 multiply 9, so you get 720 centimeter cube. Okay, a quick revision about the conversion of units. 1 liter is equal to 1000 milliliters, or you can say centimeter cube instead of milliliters. They are equal units to each other. Now, after we are done with the difference between mass and weight and how to measure the mass and weight, mass and volume, now we're going to figure out the difference between mass and weight. Okay, again, so we have already figured out the difference between mass and volume. Now we're going to figure out the difference between mass and weight. We understood that mass is the amount of matter in the object. Okay, now when it comes to the weight, there is a very common misconception that when you measure your mass on the balance, you're saying that you're measuring your weight. This is actually not correct. What you're measuring on the balance is the mass, is your body mass, while in fact weight is a different thing. Actually, the weight is the pulling force of the earth on your mass and on any object on any planet. Again, the weight is the earth's gravitational force on an object mass. Okay, so we can measure it by using a totally different tool, which is the spring scale, or we can call it the Newton meter or the force meter. Okay, and the unit is newtons. There is a certain formula from which you can get the weight. Okay, so because we agreed that the weight is the pulling force on a certain mass, okay, they got that the gravitational force of Earth is already 10. This is an agreed value all over the world. Okay, they have measured the value of the gravity and they found it to be 10, right? And you multiply this gravity by any mass, you get its weight, right? And we have already mentioned these examples, so simply you multiply by 10, you get the weight of the object if you are given the mass. And definitely please don't forget to write the unit, because units are always graded by 1 mark, right? Another example, simple compensation. Please don't forget to write the formula in the very beginning and then compensate in the formula, right? Now, because we agreed that mass is just the amount of matter in an object, so it's never changing whenever you are traveling to any of the other planets or even the moon, right? Now, because weight depends on the gravity, so weight might be different, and it is different. So there is a very big difference between mass and weight, and we're gonna spot this in the next table. So, for example, if you are on the moon or on Earth, your mass is still 120 kilograms. This is something constant. Constant means it doesn't change. Okay, you're not going to lose any amount of matter when you travel from the Earth to the moon. Why? Because the gravity on the moon is 1/6 the gravity on the Earth, or in other words, the gravity on the Earth is 6 times the gravity on the moon. So actually now the weight is going to be different, because on Earth you multiply by 10 to get the weight, while on the moon you multiply by 10/6. So your weight on the moon is going to be 6 your weight on the Earth. Or in other words, your weight on the Earth is 6 times your weight in the moon. And you're going to have many questions about this point, right? So simple comparison. Now the mass is calculated in kilograms while the weight is in newtons. Okay, mass is only a value while the weight has a direction. Why do you think? Because actually the gravity has a direction. The gravitational force is a force, and forces have directions. Okay, now we measure the mass by using the balance, while we measure the weight by using the spring scale or Newton's meter or the force meter. The three names are the same. Here we go, measuring the temperature. And we can measure the temperature either by using the mercury, the traditional thermometer, okay, or we can measure it by the digital thermometer, which gives you numbers, and the digital thermometer benefit is that it is more accurate than the mercurial one. Now, the alcohol thermometer is actually used to measure the temperature that are way below -38, because mercury freezes at -38 while alcohol freezes at -114. And there are some areas all over the world where the temperatures are really low. So in this case, they are using the alcohol thermometer. Temperature is measured in many units, and we agree that degrees Kelvin is the standard international unit, while in many cases in the checkpoint exams or in the common exams, we are going to find that temperature is unit is degrees Celsius, and this is the most common one in the exams. Now, moving to dynasty, I have already explained to you that dynasty in a very, very simple meaning, it's the crowdness. Okay, you will never say crowdness in the exams, but this is a simple way to make you understand the definition of density. So density is the mass, okay, in a certain volume. Obviously, if you have a dense street, for example, or a crowded street. So you have many people in a certain volume, which is the street. Okay, so density by definition is the mass per unit volume. And as shown here in the presentation, because solids have so many particles packed together and they're occupying less space, okay, so this means that solids are more dense. Again, why? If we arrange the substances, the states of matter from the least dense to the most dense, we're going to find that why the gas is the least dense, because fewer particles are present in the same volume, right? Okay, here we go. So which one is more dense? From the squares, as you can see here, that both squares are of the same volume, right? But the one on the right hand side has more particles than the one on the left hand side. So since it has more particles, so this means that it has more mass, and the higher the mass, the higher the density. Again, when the mass increases, the density also increases. Okay, you can easily memorize this rule in order to do any calculations regarding the density. Okay, and please don't forget that the unit of measuring the density is the mass, the unit of the mass given per the unit of the volume given, whatever the mass unit given and whatever the unit of the volume given. So for example, the density could be grams per centimeter cube or kilograms per meter cube. Okay, or it could be grams per meter cube. Okay, so it's the unit of density in brief is the mass unit per the unit of the volume, right? And we have already done these calculations as some examples for how to measure the density. Okay, we have stopped so far at this. Hopefully this recording is going to be very helpful for you guys. Thank you very much for being with me and have a nice weekend. Bye bye.